I'll try going over the quiz if I have enough time, but right now I'm kind of focusing on getting this lecture done. All right, so if you look at it, it's pretty much impossible for somebody to have a type O or a type A blood, because if you look at it, we either have type O or we have type A. We don't have a type where it says type O and type A. So for this one, we have mutually exclusive. So when we find this probability, so when we find the probability of type O or A, you only have to find the probability of O and add it to the probability of A. So how many people have type O blood?
194. I mean 184.
There you go, perfect. So 184, and you divide this by the total. The total is 409. That's the total. How many people have type A blood?
164.
Yeah, 164 over 409. So then if I go 184 plus 164 over 409. Let's do that. So you got 184 plus 164. That give you 348 over 409. So then if we do 348 divided by 409, you get 0.8509. And that's it for that first problem. Any question in regard to this first problem? All right, second problem. So if you look at it, it's exactly the same table. The only thing different is the question that it's asking us. So we want to find the probability the donor has type B or a RH negative. So here go my type B. Here go my RH negative. So if you look at these are not mutually exclusive. The reason they're not mutually exclusive, sorry about that. If you look at it, the reason why they're not mutually exclusive because there are people who are RH negative and have type B blood. So for this one, they're not mutually exclusive. So when I go ahead and find the probability that they have negative or type B, you have to find the probability they have a negative RH, add it to the probability they have type B, and subtract it by the probability they're negative and type B. So if you look at how many people have a negative or RH negative, it tells us there's a total of 65 people who are RH negative. So you go 65, and you want to divide it by 409. Then you want to add it. So for this one, you add it to the probability of B. So the probability of B, if you look at it, we have 45 all over 409. And then you want to focus on the people who have negative and type B blood. So that's these people. If you look at it, these are the people who got overlapped. If you look at where I selected type B and then RH negative is where do they intercept. So we subtract it by 8 over 409. So you're going to do 65 plus 45 minus 8, all divided by 409. So we go 65 plus 45 minus 8. So if you do that, you get 102 divided by 409. If I do 102 divided by 409, you get 0.2494. So there's a 24% chance that somebody if we randomly select somebody, that they'll have either Rh negative or their type of blood will be B. All right, and that's it for that second question. Any question in regard to that problem? All right. So if you look at this one, it says find the probability that the donor has type B. So here you go, type B, or type AB. So if you look at these two types, they're mutually exclusive because you can either have type B or you can have type AB, but you can't have type B and type AB at the same time. You either have type B or you have type AB. So let's go ahead and find this. So you get type B or AB. So for this one, all you have to do is get the probability of B added to the probability of AB. The probability of B is 45 out of 409 plus the probability of B, which is 16. All over 409, so you get 61 over 409. So you go 61 over 409, and you get 0.1491. And that's it for that one. So if you look at this one, this was the mutually exclusive one because a person will either have type B or they'll have type AB, but they can't have both of those type at the same time. Any question for this last problem? All right. All right. So the last one. So find the probability that the donor has type O blood or is Rh positive. So here you go, Rh positive. Here you go, type O. So if you look at it, they intercept. Since they intercept, that means they're not mutually exclusive. So what we have to do, we have to say probability of positive or type O is equal to the probability they test positive, or sorry, not test positive, that they're Rh positive. So that's 344 all over 409. And then what you want to do, you want to add it to the people who are type O blood. So type O blood will be 184 all over 409. And then subtract it by the overlap. So the overlap is the 156 all over 409. So let me go ahead and do that. So you do 344 plus 184 minus 156. And you get 372 all over 409. So then if I do 372 divided by 409, you get 0.9095. And that's it for that last problem. Any question for that last problem?
Yeah, I'm actually confused.
Okay, what are you confused with?
Like, how do you know how to place the positive and the O, the type O blood? Like in the beginning of the problem? Like, how do you know which goes first?
For that one, really doesn't matter. You could have placed it like this, and then you go 184 over 409 plus 344 over 409, and then minus 156 over 409, and you'll still get the same answer.
Oh, okay.
Because for the or statement, it doesn't really matter which one you put first. So you can either put positive or type O, or if you want, you could put type O and then positive. But you should still get the same answer because when you're adding them, you're still gonna get the same answer. If I do 344 plus 184, or if I do 184 plus 344, it's the same thing.
I have a question.
Yeah, what's up?
When they're not mutually exclusive, is that when you subtract where it overlaps?
Correct. When they're not
Oh,
mutually exclusive, that's where you subtract where they overlap. Because if you look at
so,
this one,
uh,
if you look at this one is not mutually exclusive, so you subtract where they overlap. If you look at the last one, they are mutually exclusive because they don't intercept. So for that one, you do want to subtract, or you don't want to subtract it. Because if you look at what I did, I just added them.
yeah. Okay, thank you.
Yeah. Good. Any other questions? All right, so that was it for yesterday's lecture. So let's do today's lecture. All right, so today we're gonna go over a discrete probability distribution. So when we talk about discrete numbers or discrete variable mean that all the numerical value are always gonna be a whole number. So if you look at this one, they're all whole numbers. You're not gonna have anything like 0.56732 It essentially should be either 0, 1, 2, 3, but anything else is not possible. So whenever we say we have a discrete random variable, you're pretty much just checking to see if the numbers are countable. So like if I ask like how many people are in class today, like that's something that I could count, because I could go like, okay, there's 5 people today in class, or there's 25 people today in class. So that's something I could count. But if I ask you like, how long did it take you to get ready today? Like that's something I can't really count, because for that one, you could tell me, okay, it took me 20 minutes, or you could tell me it took me 20 minutes and a half, or you could tell me it took you 10 minutes. But that's something that you could actually get like a half of a minute, because we're not going to be always exactly on that minute. All right. So that's a discrete random variable. Any question for the discrete random variable? So up next, we're going to do a continuous random variable. So for a continuous random variable, it said it's possible that your answer could be a whole number, but it is also possible that your answer could be a decimal. So for continuous data set just mean like it could be a whole number, but you could also get like a fraction of a number. So like I was saying, where like how long did it take you to get ready today? For that one, it's possible that you could have gotten exactly ready like in 10 minutes, but it's also possible that you took like 10 minutes and 20 seconds. So that's not exactly a minute. So anytime you could get like half of a something, or a quarter of something, or 3/4 of something, that's telling me it's not countable, that it should be considered continuous. So right now we're gonna go over some example, and you're just gonna tell me if it's discrete or if it's continuous. So if you look at part A, it says the number of light bulbs that burned out in a room of 10 light bulbs in the next year. So is that something that I could count, or is that something that I could get like half of a light bulb burned out or something like that?
No, you can count it.
Yeah, I could count it. So since I could count it, this should be considered discrete. What about the number of green M&M in a bag? Is that something that I could count, or that's something that like is really not countable?
It's discrete too.
Yeah, perfect. What about the length of time between call to 911?
Continuous.
Yeah, perfect. Continuous. How about D? How many coin a person has in their pocket?
Discrete.
Yeah. The distance from here to the moon.
Continuous.
Great. All right, good job. All right, so those are your example for discrete and continuous. Any question in regard to that?
Why
Sure.
is the move on this continuous?
What was that again?
Oh, never mind. No, never mind.
All right. So let's scroll on down. All right. So there are some rules for the discrete probability distribution. So when I talk about discrete probability distribution, I'm talking about the table. So we're gonna have an x, and then we're gonna have a p of x, and then we're gonna have something here, something here, something here, something here, something here, something here. So there are some rules in order to see if this table is a probability distribution. So two things that we're going to check to see if our table is a probability distribution. Well, the first thing you kind of want to check on, you want to check on this one. So that one is saying that you have to check this column right here. And you have to make sure that all of the probability are between 0 and 1. So it's telling us that we can't have a probability that's bigger than 1, but also we can't have a probability that's smaller than 0. So if you get like a number like negative 0.5, well, you should already know that's not a probability because you can't have any negative. Or if you have a probability like 1.2, that will also be considered wrong because you can't have a probability bigger than 1. So what this is telling us, all of our probability has to be between 0 and 1. Anything above 1 or anything below 0, make this not a probability distribution. So that's the first thing that you want to check. The second thing that you want to check, since the table is listing out all of the outcomes that are possible, when I add the probability, it should always add up to 1. So that's what that first one is saying, that summation of p of x is equal to 1. It is saying that once you add all of the probability, it should always add up to 1. So what we're going to do, we're going to go ahead and check out these next example. And all we're going to do is say, is it a probability distribution or is it not a probability distribution? So let's check these out. So let's check out the probability. So if I'm checking these probability, do we have any probability higher than 1 or any probability that's negative? Yes or no?
No.
Cool, no. So since we don't have any probability higher than 1 or less than 0, this one checks out. So now what I want to do, I want to check out to see if I add up all the probability, does it add up to 1? So we're going to say 0.28 plus 0.21 plus 0.43 plus 0.15. And we want to see, does that add up to 1? So I'm going to just add that up in my calculator. You should be doing the same. So if you add up those four probability, what do they add up to?
0.07.
Yeah. So they add up to 1.07. So this is not equal to 1. So this fell. So where is it? This is not a probability distribution. And that's it for that solution. So you want to check both of those conditions. If one of those conditions doesn't pass, then pretty much you can just stop and you say this is not a probability distribution. Because in order for it to be a probability distribution, both of the conditions must pass. If one or both of them fail, then you know it's not a probability distribution. Any question for that first one?
No.
Let's try the second one. All right. What about this one? Let's check this first one. If I look at these probability, are all these probability between 0 and 1?
No.
Yeah,
No.
no. If you look at it, we actually have two of them. We have this one, which is -1, but we also have 5/4, which is also above 1. Well, not also, but we have one that's below 0, and we also have one above 1. So this condition fell. So we're gonna say this is not a probability of the model distribution. So we're gonna say this is not a probability distribution, and that's it for that second problem. So as soon as you notice that, hey, you have that negative, you want to say that this is not a probability distribution. Any question for that second problem? All right, let's do this third one. All right, so let's first look at the probability. If you look at the probability, we don't have any number above 1. Also, we don't have any number below 0. So for this one, this checks out. So now what we want to do, we want to check out to see if I add all of those 4 numbers, do they add up to 1? So we're going to do 0.09 plus 0.36 plus 0.49 plus 0.06. So let me do this in my calculator. You should also do it in your calculator. So we get 0.09 plus 0.36 plus 0.49 plus 0.06. Cool. If you do this, they actually add up to 1. Since they add up to 1, this condition is also met. So we'll say this is a probability distribution. Right. And that's it for the last problem. So if both conditions are met, you say they are a probability distribution. If one or both of them are not met, then you say this is not a probability distribution. Any question for that last problem? All right. So let's do this one. So let's check to see. All right, so let's look at those 4 probabilities. So for those 4 probability, do we have any of those probabilities that are bigger than 1 or negative?
No.
Yeah, if you look at them, all of them are pretty much between 0 and 1, because you wouldn't know if you have something bigger than 1, because if you have something bigger than 1, the top number will be bigger than the bottom number. So, but if you look at all of these numerator or the top number are smaller than the bottom number. So that's how you know none of them are above 1. And if you look at them, none of them are negative. So what we want to do, we want to add them all. So we want to do 1 over 16 plus 5 over 8 plus 1 over 4 plus 1 over 16. And we just want to add them all up. So here, we can actually do this in class count. Let's go to class count. All right, so in class calc, we could either do 1 divided by 16. Then we'll say plus 5 divided by 8. Then we'll do plus 1 divided by 4 plus 1 divided by 16. All right, so if you look, if you add all 4 of those fractions up, they actually add up to 1. So both conditions are met, so we'll say this is a probability distribution. And we're all done with this problem. So if you look right here, I put this is a probability distribution, and we're done with that one. So let's scroll on down. All right, so now we're gonna be finding the mean, the variance, and the standard deviation of our probability distribution. So once I know it is a probability distribution, you're able to find all of these things. So we're able to find the mean, we're able to find variance, or we could find standard deviation. So what we're gonna go ahead and do, we're gonna go ahead and do this problem. Well, let me give you a minute for that way. If you're writing this down, you can write it down. All right, let's scroll on down. So here go our data set. So what we're gonna do, so it says the probability distribution for the personality inventory test for passive aggressive trait is given. Find the mean, the variance, and the standard deviation. So what we're gonna go ahead and do, we're gonna find the mean, and then we're gonna find the variance, and then we're gonna find standard deviation. So for the mean, so right now we're gonna get practice on the mean. So if I just want to find the mean, the only thing I have to do, I have to get x and multiply it by p of x. Okay, if you look at the formula for the mean, it says you get the summation of x times p of x. So you first want to do this portion, you want to do x times p of x, and then once you do x times p of x, you add them all up. So let's go ahead and do this. So the first thing I'm going to do 1 times 0.16, which give me 0.16. Up next, I'm going to do 2 times 0.22. So we do 2 multiplied by 0.22, which give me 0.44. Then you could do 3 times 0.28. And for this one, let me get the calculator to do this one for me. So 3 times 0.28, that's 0.84. So if I do 4 times 0.20, 4 times 0.20 is 0.80. If you do 5 times 0.14, that should give you 0.70. 5 times 0.14. All right, everybody good on how I got those numbers? All right, so what I want to do for the mean, to calculate the mean, I'm going to get those 5 numbers and I'm just going to add them all up. There you go, 0.16 plus 0.44 plus 0.84 plus 0.80 plus 0.70. So you get 0.16 plus 0.44 plus 0.84 plus 0.80 plus 0.70, and you get 2.94. So we'll say the mean is equal to 2.94, and we're done. So that's all you have to do for the mean. You don't have to do anything else. You have to get x multiplied by p of x, and then what you want to do is add all of those numbers up. All right. Any question on how I did that?
In this one, we don't have to divide or anything.
No. No. For this one, all you have to do multiply each other, multiply the x times the p of x, and then add them, and you're done.
Okay.
So now let's go ahead and let's look at the formula for variance. So for the formula for variance, if you look at it, it's a sigma squared is equal to the summation of x minus mu squared times P of X. So I'm going to add this new table, and this new table is just for variance. No, there you go. So if you look at this formula, we're first going to do this part over here. Oh, I think it showed up. We're going to do this part over here. So I'm going to do x minus mu, and I'm going to square it. So let's do x minus mu. So we get x minus mu, and we square it. All right. So I'm not going to have enough space to write it there, but we do it over here. So if you look at it, I already know mu. So mu is equal to 2.94. So it's saying you get x, and we subtract it by mu. So we'll do this for 1. So we'll say 1.294, and then we square it. Any questions so far? I got 1 minus 2.94 to the second power. All right. So if I do 1 minus 2.94, you get negative 1.94 squared. So if I get negative 1.94 squared, I'm going to do that on my calculator. You roughly get 3.7. So we'll put 3.7 here. So also notice the negative will disappear because anytime you get a negative and square it, it becomes a positive value. Right. So now I'm going to do it for 2. So let's do a different color for 2. Let's do blue. So 2. So now we're going to say 2 minus 2.94 squared. That's equal to negative 0.94 squared. So if I do negative 0.94 squared, you get 0.9. If you did this on the calculator, you actually get 0.8836. But since we're going to use one decimal place right now, you could just round it up to 0.9. So this will be 0.9. All right, now we're going to do this for 3. So for 3, we'll say 3 minus 2.94 squared is equal to 0.06 squared. So we'll say 0.06 squared. This one you actually get 0.0036. So we'll just keep that one because it doesn't have any one digit. So now let's do this for 4. So for 4, we'll say 4 is 4 minus 2.94 squared. If you do 4 minus 2.94, you should get 1.06. You square it, so we'll say 1.06 squared. And for this one, you actually get 1.1. And lastly, we're going to do 5. So for 5, we'll say 5. So we'll say 5 minus 2.94 squared is equal to 2.06 squared. So you go 2.06 squared, and you get 4.2.
I have a question.
Yeah.
Would the first one be 3.8 because it's 3.76?
Oh yeah, thank you for that.
You're welcome.
3.8.
Mm-hmm.
All right. So that's it for that portion. Any question in regard to how I got that portion? All right. So if you look at it, now what we have to do, we have to multiply by P of X. So I have to get this row or this column right here, and now we multiply by this. So let's add that over here. So we're gonna say X minus mu squared times P of X. All right, so all we have to do is get P of X and now multiply by the row that I just got. So for this first one, what we had to do, oops, sorry about that. We had to get, stop it. We had to get 0.16 and we multiply by 3.8. So if I do 0.16 multiplied by 3.8, we'll get 0.16 multiplied by 3.8, and you get 0.6, we'll just say 0.6. Now what we're gonna do, we're gonna say 0.22 multiplied by 0.9. There you go, 0.22 times 0.9. And this is 0.198, but we're gonna just round this off to 0.2. So now we're gonna do this number and this number. So we're gonna say 0.28 times 0.0036. So 0.28 times 0.0036, and you get 0.001. Then I'm gonna get 0.2 multiplied by 1.1. So you get 0.2 multiplied by 1.1. So 0.2 times 1.1, and you get 0.2. And lastly, we're gonna do here. Lastly, we're gonna do 0.14 times 4.2. So we'll say 0.14 times 4.2, and that's gonna give me 0.14 times 4.2. That should give you 0.588, which where you're gonna round it off to 0.6. So we're gonna say 0.2, 0.001, 0.2, 0.6. Any question on how I got those numbers for the last column? All right, so the last thing what I want you to do is, so I already did this portion, I already did this portion, I already multiplied the two portion. All we have to do now is add them up. So take a minute and add them up right now.
I'm sorry, which one are we adding up?
You're gonna add up these right now.
Oh, okay. So once we add all of these up, what do they add up to? All right, cool. Thanks, Ashley. So they should add up to 1.601. And this is your variance.
So once you get the variance, well, any question how we got that variance?
Yes. All the numbers you got right, like the 46.
I think you were breaking up. I can never understand.
Is there a way to do the same thing on class calc, or do we have to do it this way?
For
Like
the mean, no, like I'll show you right now how to do it class count.
okay.
So the last thing, if you want to get standard deviation is this. So we take the square root of 1.601. So if I take the square root of 1.601, you get standard deviation of 1.27. And that's it. Any questions so far on this? All right. So there is a way to double check your answer using ClassCal, or also like for the quiz that I've been noticing, like students are not following instruction. Like the question will tell you you could use your calculator, and yet you still would do it by hand. So if the question said you could use your calculator, that means you could just pretty much just do it in your calculator and not have to worry about doing it by hand. So if you do see that says just use your calculator, just use your calculator to do it. So right here, what we're gonna do a table. So on x1, we're gonna put x. So we're gonna play 1, 2, 3, 4, 5. All right, so then for y1, where you're gonna put p of x. So p of x is 0.16, 0.22, 0.28, 0.20, and 0.14. So then what you want to go over here. So if you remember from last time, when we did the frequency list, you want to use the frequency list again. So we want to go to stats. You want to go to advanced. And you want to go to frequency list. So I'm going to say x1 is my x. And I'm going to say y1 is my frequency. Didn't like that. That didn't work. Here, let's try doing something else. Okay. So what we're gonna do right here, we're gonna convert all of these into a whole number. So you see how it says 0.16? So if I want to convert this to a whole number, we're gonna convert it to 16. If you look at 0.22, we're gonna convert this to a whole number. So we're gonna say 22. If you look at 0.28, we're gonna convert that to a whole number and we're gonna say 28. If you look at 0.20, convert that to a whole number, you're gonna say 0.20. Lastly, for this one, 0.14, we're gonna convert it to a whole number, we're gonna say 0.14. So essentially what I did here, I multiply all of these by 100. So for this one, you just multiply all of these numbers right here by 100. Because pretty much what we wanna do, we wanna make them into whole number. For that way, ClassCal could be able to recognize it. Everybody good so far on multiplying y1 by 100?
Yeah.
All right. So then where we're gonna go here, we're gonna go stats. We're gonna go to advanced. Once again, we're gonna do frequency list. So we're gonna say X1 is frequency list 1. And we're gonna say Y1 is our frequency list. So it should say 100 element. So now what we're gonna go ahead and do, we're gonna go to stats, we're gonna go to advanced, and we're gonna do 1 bar stats. So don't forget for the frequency list, you have to call it a variable. So you say A is equal to this variable, or A is equal to the frequency list. And then you do 1 bar stats of A. So if you look at the mean is turned out to be 2.94. So that's a way they double check to make sure they're giving you the correct answer. Because if you remember when we did the mean, we got 2.94. And for this one, since we have proportional data set, we're going to use standard deviation right here. So if you look right here, it gave us 1.27. And if you remember what we got 1.27 for the standard deviation. So that's how you could do it with class count. So you have to do the X list and the Y list. But just remember for the probability, you just multiply them by 100. For that way, class calc will recognize it.
Thank you.
Yeah, no
Did
problem. All right, so let's go to the next problem. So for the next problem, you're gonna do this one in class calc. So let me go back to the problem. So we're gonna do this next problem. So what we're gonna do, we're gonna find the mean, the variance, and the standard deviation. But for this one, what we're gonna do it in class calc. So if you look at my x value, you put that in x1. P of x, you want to enter this into y1. But remember, for this one, multiply everything by 100. So that way, class calc will be able to recognize it. So let me go over back to class calc. And let's punch this in. All right, so first thing, we do a table. So we enter it in the number, so 0, 1, 2, 3, 4, 5, 6. Oops. So 3, 4, 5, 6, and 7. So over here on Y1, we're going to enter P of X. But remember, P of X is entering at the whole number. So where it says 0.16, you do 16. 0.19, you do 19. 0.15 is 15, so on and so forth. Any question on the table? All right, so now we're gonna go over here where it says stats, we're gonna go to advanced, and we're gonna do frequency list. So we're gonna say X1, and then you put Y1 for the frequency. So if you look right here, it should say 100 element. For this one, it should always say 100 element. Because remember, this has to add up to 1. So if you do 1 times 100, you should get 100. So that's how you know you're on the right track. If this add up to something other than 100, you might have put the Y1 wrong. All right. So then if you want to find the mean, you can just say mean of A. So that's your mean of A. If you want to find the variance, you can just say variance of A. All right, that's your variance. If you want to find standard deviation, you put standard deviation of A, and that's your standard deviation. So for this one, we'll say mean is equal to 2.6. Our standard our variance is equal to 3.72. and standard deviation is equal to 1.9. We'll say 3. And that's it for that last problem.
I have a question.
Yeah, what's up?
Why are you putting the A before frequency list instead of how you taught us to put like the X1 and Y1?
You're talking about this A?
Yeah, and
Well, because if I don't put it, then it doesn't know, like for the mean, we're not going to know what to put in for the mean. Because then what you have to do, you literally have to put the frequency list for all of them inside of it. So you have to do this. So you have to do frequency X1,
oh, okay.
Y1.
Okay.
So instead of you having to constantly having to repeat that, it is easier to say A is equal to this. And that way, instead of having to enter frequency list of X1, Y1, you can just say A.
Okay.
So it's like a shortcut. Any other questions? So yeah, so like for the mean should be doable by hand, but for the standard deviation, you do standard deviation using the calculator. Like you're not gonna lose anything. All right, sweet. So those are the answer I got. So I got mu is equal to 2.6. I got variance to be 3.72. And actually I got sigma to be 1.93. So that's your final answers. Any question for the final answer? All right. So let's go ahead and do this. So up next, what I want you to be able to do, just be able to read the table. So here is my table. So it said below the probability distribution for the number of math failure BC students. So we have 0 failure, 1 failure, 2 failure, 3 failure, 4 failure. So right here we have 0.39, 0.28, 0.06, 0.04. So if you kind of notice, we're missing this 2 right here. And that's the very first thing we want to find. So how can I find that 2 if I know everything else? Like, what should all of the probability add up to?
1.
Yeah, 1. So what I could do, I could say, oh, geez. Why? So what I could do, I could say, okay, all the probability should add up to 1. So I could add up the probabilities. I could do 0.39 plus 0.28 plus 0.06 plus 0.04. So let's add them up. So we'll say 0.39 plus 0.28 plus 0.06 plus 0.04. So you get 0.77. So how much do I need in order for it to add up to 1? Well, if I want to find that out, I can just say 1 minus 0.77. And if I do 1 minus 0.77, we get what?
0.23.
Perfect. So you get 0.23. So that means 2 is 0.23. All right. So that's it for number 1. Any question for number 1? All right, let's do number 2. So if you look at number 2, it says probability that x is less than 3. So if x is less than 3, that means we want all of these. Because we want numbers that are lower than 3, so we want a number like 2, 1, and 0. So what we want to do for this one is add up the probability. So we get 0.39 plus 0.28 plus 0.23. And let's see, what do we get? 0.39 plus 0.28 plus 0.23. So if you look at it, you get 0.90. And that's it for 3. Any question for, any question for number 2? All right, let's do number 3. So if you look at number 3, now it has the equal sign. So the equal sign means it could be less than 3, but it could also be equal to 3. So now what we want to do, we want to include the 3. So now we're going to do 0.39 plus 0.28 plus 0.23 plus 0.06. So now if I add all of those four numbers up, you get 0.96. Any question for 0.96? All right, let's do 4. So for 4, it's probably that x is less than or equal to 1. So if we want it to be less than or equal to 1, that means you want to include these two numbers because 0 is less than 1 and 1 is equal to 1. So we want to get 0.39 and add it to 0.28. So let's say 0.39 plus 0.28, you get 0.67. All right. Any question on this so far?
No.
So last two. So this one say probably that x is greater than 2. So that's these two values over here. So we want 3 and 4. So we want to get the probability of 3, which is 0.06, and get the probability of 4, which is 0.04. If you add that up, you get 0.10. All right, lastly, if you look at it, we want to get number 6, which is probably x is equal to 2 or x is equal to 3. So that means we want these two values over here. So if you do the probability that x is equal to 2 and then add it to the probability that x is equal to 3, you get 0.23 plus 0.06, which is 0.29. And that's it for that problem. Any questions? So you do kind of want to know how to read these tables. So that way in a test or in a quiz, like it shouldn't be that difficult to get the probability of it. So for these, all you have to do is you look which x value do you want, and then you have to add those x value up. All right, so let's go down. So up next, we're going to do something called the expected value. But the expected value is the same thing as the mean. So if you look at the formula, it's exactly the same formula. You get x multiplied by p of x, and then you want to add them all up. So there's nothing new. It is, we call it a different name. So if you ever see them ask you find the mean or find the expected value, just know both of them are the same thing. So let's do a problem where we want to find the mean. All right, so for this one, it says at a raffle, 1,500 tickets are sold at $2 each for 4 prizes of 500, 250, 150, and 75. You buy one ticket. What is the expected value of your gain? All right. So for this one, we're going to create this table. So we're going to actually have to create the table to be able to figure out these to figure out this next part. So first thing we're going to go ahead and do, we're going to list out how much money can this person win. So how much money can the person win?
500, 250, 150, and 75.
All right, perfect. So we'll start from lowest to highest. So we'll say $75, 150, 250, and $500. Cool. But we forgot one of them because it's also possible that the person win nothing. So 0. All right. Everybody good so far? I got the X value of pretty much the money that they earn or the money that they win. All right, so P of X is going to be the probability of them winning. So for this one, there's only 4 prizes. So one person going to get $500, one person going to get $250, one person gonna get $150, one person gonna get $75. And then that means everybody else is gonna lose. So how many tickets were sold?
1,500.
Yeah, 1,500. So right here we'll put 1,500, 1,500, 1,500, 1,500, 1,500. But now what we have to do, we have to say how many winning tickets are we gonna have. So for 500, how many people are gonna win?
One.
Oh, one. So you put one. So same thing for 250. For 250, only one person is gonna win. So you put one. What about for 150? How many people are gonna win $150? Well, just one. How about the $75? Well, same thing, just one. And lastly, how many people are gonna win $0? So if we're gonna have 4 winners and they sold 1,500 tickets, how many people are gonna win nothing?
1,496.
Perfect. So what you have to do, you have to do 1,500 minus 4. So you get 1,496. So any questions so far? I got those fractions. All right. So we're gonna go class calc and we're gonna we're just gonna let the calculator or class calc do the work for us. So let's share class calc. Share. All right, so let's erase. All right, so we're gonna do a table. So we do x1, so x1 is 0, 75, 150, 250, and 500. Now we're gonna do y1, where y1 actually for this one, here for this one, we're gonna do the multiplication. So we're gonna multiply. So we're gonna do 0, and we're gonna multiply this by 1,496 divided by 1,500. Then you're going to add this to 75 multiply by 1 divided by 1,500. Then into the next one. So then we say add 150 multiply by 1 divided by 1,500. And then we're going to say add it to 250 multiply by 1 divided by 1,500. And now we're going to do the last one, which is 500. So we'll say 500. Oops, if you look at that, I forgot to put the addition. That's no bueno. Let's do addition. All right. Let's do addition. And let's do 500 multiply by 1 divided by 1,500. So if you look at that, you get 0.65. So you get the mean as 0.65. Everybody get on the mean being 0.65? So let's go ahead and go back to my notes. So if you look at it, it's telling you the mean is 0.65. So that means every time you play this game, you're expected to win 65 cents. But if you look at it, so that's how much you're expected to win every time you play. But if you look at how much the ticket costs $2. So that means every time you play this game, you're actually losing money, because if every time you play the game, you have to pay $2 and your expected winning is 65 cents, that's telling us every time you play this game, you're losing $1.35, because pretty much if you do 2 minus 0.65, you get $1.35. So every time you play the game, you're losing $1.35. All right, and that's it for that one. Any question on how I did this last problem?
So you just basically, on the class calc, you just added them, right? Like 75 in front of each fraction, right?
Yeah, so you pretty much multiply all of these and then you just add up the numbers. Because if you look at what I did in class calc, can you see how I did like 150 times the fraction, and then you add it to then 250 times 1 divided by 1500. So you multiply them and then you just add it up all the number. But instead of doing that like in steps, I did it all in one turn. All right. All right. So let's do one more. And then that's it for today's lecture. So this one said, at a raffle of 2,000 tickets or so at $5 each for 4 prizes of $2,000, $1,000, $500, $250, and $100. 2, 3, 4, 5. So that should say 5 prizes. So there's 5 prizes, not 4. So let's say you buy 1 ticket. What is the expected value of your game? All right, so once again, we're going to do this table. So 1, 2, 3, 4, 5, 6. All right, so let's go ahead and do this. So for this one, X, you get to put how much money you could win. So the lowest amount of money that I could win is $0. Then it's $100. Then it's $250. Then it's $500. Then it's $1,000. And then it's $2,000. Any question in regard to X? So now for the P of X, since I have 2,000 tickets, or since 2,000 tickets were sold, all of these should be 2,000. So you divide it by 2,000. So for this one, how many people are going to win $2,000?
One.
Yeah, 1. What about $1,000?
1.
What about $500?
1.
Cool. So all ones over here. How many people are going to win nothing?
1,995.
Perfect, thank you. 1,995. So if you do 2,000 minus the 5 prizes, you get 1,995. All right. Everybody good with that so far? All right. So if you look at it, what we're going to do, we're going to multiply these out. So we'll do X times P of X. So if I do 0 times anything, you're going to give me 0. So I'm going to put 0. So 100 times 1 divided by 200 is 100 divided by 2,000. Same thing for 250 times 1 divided by 2,000. It will be 250 divided by 2,000. Then you get 500 divided by 2,000. You get 1,000 divided by 2,000. And lastly, you get 2,000 divided by 2,000. Everybody good so far with those fractions?
Yes.
All right. So then what you want to do with those fractions, you want to add them all up. So you do 100 divided by 2,000 plus 250 divided by 2,000 plus 500 divided by 2,000 plus 1,000 divided by 2,000 plus 2,000 divided by 2,000. So you want to do 100 plus 250 plus 500 plus 1,000 plus 2,000. So let me do that in my calculator. So 100 plus 250 plus 500 plus 100, well, 1,000, sorry, plus 2,000. You get 3,850 divided by 2,000. So if you do that divided by 2,000, you get 1.925. So that will be our mean, 1,225. So sorry, not 1,225. It's 1.925. So that's telling us we're expected to win roughly $2 every time we play this game. But the thing is, we have to kind of remember we're winning $2 or approximately $2, but every time we play the game, you have to pay $5. So if you're winning $2 every time, but every time you have to pay $5, you're essentially losing $3.08 every time you play the game. So on the long run, you're gonna be losing money because essentially you're only winning $1.92. But since you have to pay $5 to play the game, you're always gonna be losing money. All right, and that's it for the last prong. Any question in regard to the last prong? All right, so that's it for today's lecture. So I'm gonna go over yesterday quiz, and then I'm gonna kind of give you a little preview on today quiz because for some reason the student always mess up today quiz. So I'm gonna give you some notes for that way you won't mess up today quiz. Yes. Summer. All right. All right, so this was yesterday quiz. So if you look at the left side, it had the year. If you look on the right side, it had tons of solid waste generated in thousands. So if you look at part A, it says given the following data on the waste generated in Florida from 1990 to 1995, find the correlation coefficient with your calculator. So if you look at it, it says with your calculator. So you don't have to show any work for part A. You just have to just do it in your calculator. So your calculator should have been class calc. So let me go over to class calc. So we'll go here, we'll go to table. Class calc, we'll say 1990, 1991, 1992, 1993, and 1994. All right, so that's your X1. So then you go 19,358, 19,484, 20,293, 21,499, and 23,561. All right, so that's your X1 and your Y1. So that should have probably been the hardest part. Then you go to stats, you go to advanced, you go lin reg, you say X1, and then you say Y1. All right. So for part A, you say R is equal to 0.9445. And that's all you had to do for part A. So that's 1 point right there. All right. Any question on how to find R? All right, so let's go back to the quiz. All right, so if you put R is equal to 0.9445, I gave you a point. All right, so for this one, it said, given the following data on the waste generated in Florida from 1990 to 1994, find the regression line with your calculator. So for this one, it's not asking to find the mean standard deviation at R to find the slope and find the y-intercept. It is saying use your calculator to find the least square regression line. So let's go back to class calc. So if you look at class calc, I already got that. Because if you see where it says y hat, that's my answer. So let me take a minute and write that down. Blah, 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 blah. All right, so all you have to do is say y hat is equal to 1042.1x minus 2055024.2. Let me make sure I got that 2550. Right, so that's all you have to do with your calculator. Right. So that was the answer for part B. So if you got this, you got another point. So then for part C, it says, given the following data on the waste generated in Florida from 1994, from 1990 to 1994, estimate how much solid waste will be produced in 1996. So you say y hat is equal to 1042.1 minus 2055024.2. And right here, what you want to enter 1998. So you enter 1998, and what you want to do, you just want to make a prediction. So, because prediction or estimate, the same thing. So you substitute 1998, and then you find the answer for that. So let's go back to class calc. All right, so in class calc, all you have to do, you put 1042.1, multiply that by 1998, and then subtract it by 20, 55, 0, 24.2. Actually, I get this wrong. So 45024.2. There you go. So you should get y hat is equal to 27,091.6. So I give you a point if you got this one correct. So that's all you had to do for C. So if you got C correct, I gave you another point for that one. lastly, it says for every year, how much waste is generated. So for that one, they're just asking for the slope. Because if you remember, I said for every, like for the slope, it's telling you like this is how much y changes whenever we add additional x value or we add 1 unit. So for this one, I'm telling you like for every year that passes, so year is your x value. So for this one, all you had to tell me was 1042.1. And you got a point for that one too. So if you look at this quiz, it was out of 4 point. So all I did, so say if you got 4 out of 4, you got a 1. If you got 3 out of 4, you got 0.75. So that's how I graded yesterday quiz. Any question in regard to yesterday quiz? Okay. All right, so I'm gonna show you today quiz. Well, not everything, but part of it. So this is gonna be what you're gonna see for the quiz. Like you're gonna have some questions over here. I just erased all of the questions right now. So you should know how to read this. So each shape has a number associated with it. So you kind of think about like a jersey number. So this one is circle number 9. So if I tell you, so if you look at how many shapes, how many total shapes do I have?
8.
Yeah, so you have 8 total shapes. So then how many odd numbers do I have?
4.
Yeah. So you have 8 shapes that have an odd number. All right, how many even numbers do I have?
4.
Yeah, 4. No. So you have to know how to read these. So if I ask you like for the odd number, you have to look for all of the shapes that have an odd number. So you go, these have an odd number. Or if I'm asking for even, is these over here. Or if I'm asking you for a star, you choose the 2 stars. So we have these 2. Cool. So you just know the numbers inside of the circle just represent, it's like their ID. So it's like, this is circle ID 9. This is square or rectangle ID 12. So use their ID. So don't think it's like how many squares or how many circles we have. It just represents the ID of that. All right, but cool. But that's what your quiz is gonna be about today. Like you're gonna have a bunch of questions over here. All you have to do is answer the question using these shapes. So just know there's a total of 8 shapes, and each shape has a number that just represents their essentially their association with that shape. All right. Any question in regards to that?
So question. So if it says like, oh, you have 2 circles, so would it be 2 over 8?
Correct. So if I were to say, find the probability of circle, you go like, okay, how many circles do I have? This one, this one. So you go 2, and you have a total of 8 shapes. So you go 2 out of 8. All right. Any other questions?
No.
All right, cool. All right, so let me just show you your homework. And pretty much that's it for today. So just remember for this quiz is going to be quiz number 9. All right, for homework, what you want to do, you want to go chapter 3, probability. So you can start doing this homework already. So you can start doing the probability distribution homework. Also, you do want to kind of go over the exam. So if you go right here, exam 2, right here you have your pre-exam. If you click it, there you go, your pre-exam. So you do kind of want to go over this for tomorrow, for that way you can ask questions about them, and that way you could be, yeah, ask questions about them tomorrow. So you do want to go over this, and that way for tomorrow, because tomorrow we're going to go over this, and then that's pretty much it. All right. But yeah, so that's the homework, and that's where you can find the pre-exam. So for the pre-exam, all you have to do is go to exam number 2, and then you click where it says pre-exam. All right. Any questions so far about anything?
Do we have to turn in the pre-exam?
No, the pre-exam is just for you to practice. So you don't have to turn in the pre-exam. It is for you to practice. All right. Any other questions?
Have you put up activity 9 and 10 up yet?
It should be 9 and 10. No. Yeah, okay, if you look right here, if you click right here, it says activity 7, 8, 9.
No, I mean your solutions, like you doing it yourself.
Oh, the solution. Let's see, contents. I forgot which one was the last one I answered. So it should be under activities. Yeah, if you look right there, I got activity number 9 solution, activity number 10 solution there. So all of that is there. Yeah, for the exam 2 is on Monday. Because pretty much this was the last lecture we're gonna do today. Tomorrow, just review, and then Monday is your test. Activity is due on Monday, so the same day of the exam. So exam and the activity are due on Monday. Also with your homework. All right. Any other question? All right. So let's stop recording.